Very well. So statistics, exam 1 solution. Use the frequency histogram to determine the number of classes. Well, you say, hey, how many bars do I have? This is my first bar. This is my second bar, my third bar, my fourth, my fifth, my sixth, and I have 7 bars, so I get 7 classes. Question 1 part B says, estimate the frequency of the class with the least frequency. So where are the frequencies? Frequencies are on the vertical axis. The least is going to be for the smallest bar in between all of these bars. The smallest bar is here. So you can just estimate the frequency, which is this number here, just an approximation estimation, like 10, 15, or similar. Estimate the frequency of the class with the greatest frequency. Greatest frequency is associated with the highest bar, which is roughly here. So it's going to be 300. Determine the class width. The class width is, since you don't have the original values, you only have a representative for each of these classes. The representatives are midpoints. Remember that. The difference between midpoints must be the same, and it's exactly the same as the class width. So here you have 34.5 minus 24.5, which is 10. We'll circle this as the final answer. And what is the mean? Well, we don't have the data. We don't have the actual data to do the calculation. So what are we going to do? We're going to read and try to analyze this graph. Remember, the mean is defined as a measure of center. Measure of center. The balancing point. So what would be the balancing point on the horizontal axis? You look at the shape of the graph. So the balancing point is about, you can say that is in the middle here, 50. And find the z value, then we can say that, hey, which one is relatively better? In psychology, the mean is 88, standard deviation is 7. So x minus mean divided by standard deviation, x is 84, mean is 88, and standard deviation is 7. Guys, you cannot change the order. You have to write it exactly the same because of subtraction. So we get negative 4 over 7 or minus 0.57. This is the z-score for psychology. Z-score for psychology. Let's take a look at this standard normal distribution. So negative 0.57, which is roughly here. Negative 0.57. This is for your psychology. The second one is for econs. It says, hey, x is 74, so let us plug in 74, and the mean is equal to 63, and standard deviation is 5. Again, do not change the order. You get 11 divided by 5, or positive 2.2. As a score, 2.2 is better than minus any negative z-score. This z-score for psychology is here. The z-score for econs is here, 2.2. So we're happy about econs and we're sad about psychology. Next page. For question 3, we can list all of these numbers from smallest to largest. This is your minimum. This is your maximum. Now we need to find first quartile, second quartile, and third quartile. You're using your calculator and entering the data in stat. You go to stat, go to edit, enter all of the data, then you go to stat, go to calc, then one variable, you can actually derive all of this information. So by calculation, Q1 must be 72. You can actually count it here. Q2 is 82. And Q3 is equal to 93. So take a look at this. You have 1, 2, 3, you have 30 data here. So since it's just positive, so let me see. This is 74%. Okay, perfect. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So Q2 for the midpoint is 81 plus 83 divided by 2, which is 82. Very well. So this is your midpoint. This is your midpoint. This midpoint divides these numbers into two sets. Now we find the midpoint, sorry, the median of the first set, the median of the first set, which is equal to 72. We find the median of the second set, which is equal to 93. So these are your 5-number summary: minimum, Q1, Q2, Q3, and the maximum. Question says find the inner quartile range. It's different from the range of the data. Inner quartile range is Q3 minus Q1, which is 93 minus 72, or equals to 21. Then it says display the data using a box plot. Okay, suppose you have your minimum, you have your maximum, and the minimum is 55, the maximum is 98, 55, 98. Very well. So where is our first quartile? 72. So 72, suppose it's roughly here. The second quartile is 82, and the third quartile is 93. Okay, 93. So let us move this a little bit here so you can actually see the shape. So 93 is here, and this is going to be your box. This is your box, and Q2, which is 82, is in the middle, all missing. This is your Q, this is your box. You can enter all of these data and actually visualize it better. Question 4 says the ages of sample of 350 employees of a software company. The ages, so when it comes to quantitative and qualitative, you should be asking, if I add these and divide them by 2, finding the average makes sense? Qualitative, quality, categorical, it doesn't make sense to find the average. Quantitative, yes, when we find the average, it's meaningful. The ages, what's the mean age of, for example, people? Yeah, it's actually a numerical or quantitative. Quant. The zip codes, it doesn't make sense to find the average of zip codes. So it's qual. The revenue, we can find the average revenue. Of course, it is quant. And the marital status, being single, being married is complicated. It doesn't make sense to find the average. So we're going to say it is qualitative. Then social security numbers. Can you do algebra? No, you have to convert all of these into dummy variables, then you can do some calculation on them. So this is another example of qualitative. Next page. Perfect. It says find the percentile. To find the percentile, we have to list all of these numbers from smallest to largest. So what would be the smallest number here in this collection? So let us list all of the 40s. So I have a 43. I have a 41. I have a 40. I have a 47. I have a 43, another 43. I have another 41. I'm going to list it here. Okay. I have a 42, so I'm going to write it here and move this guy here. I have another 43. I have 44. I have 45. Then I have, do I have 46? No, I have 47. Another 47. Okay, I'm almost done with my 40s, 48. Then I have 150 to 350s. Then I have, let's see, do I have any 51, 52, 53, 54, 53, and 54. Then I have another 54. Okay. Then I have, let's see, 56, another 56, 256. Then I have 57. Oh, I have another 56. 57. Then I have another 57. 60s. Okay, very well. I see 61. I don't see any 60. So 61, 61. And I have, let me see, 65, 66. Then I have some values less than 40, 28. So I have 28. I have 35, and I have 38. N is equal to 30, the sample size. So find the percentile corresponds to age 40. So percentile for 40. We have to count all ages less than 40. 40 is not included. So you have 3 of them. 3 divided by 30 times 100, you get 10th percentile. How about the percentile for 56? Percentile for 56. How many ages are less than 56? 3, 6, 9, 12, 15, 18, and 21. 21 divided by 30 times 100. So it's going to be 70th percentile. So which ages are above 75th percentile? Which ages are below 25th percentile? So to find the 75th percentile, we need to find Q1, Q2, and Q3. You can use your calculator, enter all of the information. You get Q1 equals to 43. You get Q2 equals to 49, the middle number, the midpoint of these two. And Q3 is equal to 56. So the 75th percentile. Remember that how we define the first quartile, second quartile, and third quartile. They divide your data set into 1, 2, 3, 4 portions. So it was minimum 25%, Q1 25%, Q2 25%, Q3 25%, and maximum. Very well. So 75th percentile, 25, 50, 75th percentile. What ages are above 75th percentile? What ages are located here? So what is your Q3? 56. So above 56, what do you have? 57, 56, above 56, 57, 57, 61, 61, 65, and 65. So 57, 57, 61, 61, 65, and 65. What ages are below 25th percentile? 25th percentile is going to be here, 25%. Less than 43. So you get 28, 35, 37, 40, 41, another 41, and 40. Question 6 says, hey, the access code for a warehouse security system consists of 6 digits. 6 digits. What's the first digit? What's the second, the third, the fourth, the fifth, and the sixth? You need to know what are these digits. Okay, it says to construct these 6 digits, the first digit cannot be 0. So how many options do I have? It's either 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. So how many? 9. So I have 9 options for the first digit. How many options do I have for the second digit? It didn't mention anything. It just says any random digit. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So how many? 10. What about the third one? Again, 10. The fourth one, 10. I have 10 different options and 10 different options. And finally, it cannot be odd. So it must be even. The last digit is even. What's the meaning of that? It means that you have 0 or 2 or 4 or 6 or 8. 1, 2, 3, 4, 5 times 5. 9 times 5. 45. How many zeros? 1, 2, 3, 4 zeros. 450,000 different options. Next page. So for question 7, you have conditional probability. It says, what is the probability that that student owns a credit card, given that, so owns a credit card, given that the student is a freshman. It means that we're not working with the rest of this data. We don't care about the rest of this data. Just given condition is important for us. Freshman. Given a freshman. It is equal to, so the freshman, the number of freshmen that you have goes on the denominator, which is 60. How many of them are credit card carrier? Only 40 of them. So 40 divided by 60, 2 thirds. Let us take a look at question 8. Question 8 says you have 56%. So P is equal to 56% of men do not look forward to going clothes shopping for themselves. Okay, you randomly select 8 men. 8. So N is equal to 8. Find the probability that the number of men who do not look forward to going clothes shopping for themselves is exactly 5. First of all, note that you have a binomial experiment. And you're looking for the probability that x is equal to 5. It means that you have binomial P, D, F, not C, D, F. So let us look at the calculator. So turn on the calculator. So let us go to second vars, and we're looking for binomial PDF. Very well. The number of tries is 8. Well, P is equal to 56%, and X is equal to just 5. Let's do the calculation. It is 0.26. So this probability is 0.26 or 26%. The second one says, what's the probability that X is more than? There is no equality, more than 5. Remember that. This is equivalent saying that you have 1 minus binomial CDF of 5. This is equal to, so let us do the calculation. First of all, we need to do the subtraction. So 1 minus second vars binomial CDF. How many tries? 8. P is 0.56. X value is 5. And paste. Enter. You get 0.24. 0.24. 24%. And finally, it says at most 5, P of X less than or equal to 5. Remember that this is just binomial CDF 5. So we go to second vars, we find binomial CDF 8.56 and 5, paste and enter. Well, you get almost 0.66. Next question. For question 9, it says, determine the missing probability. Well, we know that since we have a probability distribution, if we add all probabilities, the add of all of these decimals, even though this missing value, it must be equal to 1. So 0.07 plus 0.20 plus 0.38 plus this missing value plus 0.08 must be 1. If we do the calculation, if we add all of these together, this is just equal to 0.27. So how do we graph this? This discrete probability distribution. So we need a histogram. Very well. Suppose this is your X, and here you have your Y, which is your P of X. X is 0, 1, 2, 3, 4. So these are the representatives of each var. 0, so 1, 2, 3. Just scaling this. I want to have a nice and beautiful graph. And the maximum probability is equal to 38%. So let's just have, for example, 40% here. Remember that it must be in decimal or percentages. Okay, half 20.20. Okay, the probability that X is equal to 0 is 7%. So your first bar is going to stop at roughly 7. So suppose 7 is right just here. This is your first bar, 0.07. The second bar, 20%. When x is 1, you get 20%. So it's going to stop at 20%. Suppose this is 20%. Okay, let me just move this a little bit here. So 7%. And here we have 0.20. Then the next bar, 38%. So we're going to go up a little bit. So until we get to almost 40. This is our third bar. Point 38. Next one, we just found it. It's 27%. So 27% is going to be just roughly here. Here we go. 0.27. And finally, when x is 4, you get 8%. 8% is a little bit upper than 7%. So we're going to have 0.08 here. This is our histogram. And finally, for question 10, what do we have? A survey found that 48%, so if it's a binomial distribution, if you have a binomial experiment, it means that your p is equal to 0.48%. 48% or 0.48. On game console, 8 US households, so n is equal to 8, are randomly selected. The random variable, okay, random variable, it means that you're working with x, represents the number of the US household that own. Okay, so it counts the number of successes in our experiment. So first of all, what do we have here? Each household is different, independent from each other. So you get independent trials, and it's fixed trials, 2 independent from each other, 3 you only have successes, 2 outcomes. They either own it or they don't own it. And finally, x counts the number of successes. So since these 4 conditions are met, we say that, hey, we have a binomial experiment, and p is equal to, so this is a binomial experiment, p is equal to 48%, n is 8, well, q is 1 minus p, which is 1 minus 48%, which is 0.52, and x, it ranges between 0 to 8, 0, 1, or 3, or 4, or 5, or 6, or 7, or 8.